just discussed some examples of the latest innovative applications of constructionism. If you think the Lifelong Kindergarten Lab looks like an incredibly fun place to be, you're right. As technology advances and becomes more accessible, learners like you and your students can construct more and more on your own. Next, we'll speak with Matthew Berland, an assistant professor of digital media at the University of Wisconsin. Matt does a lot of work creating and studying games and tools that support students' creativity in learning complex concepts. We're here in Madison, Wisconsin at Games Learning Society and Learning Games Network with Matthew Berland, who's here to talk to us today. Thanks for being with us.
Thank you.
So tell me about some constructionist projects that you've worked on in the past that you think are particularly interesting.
So the most well-known project that I've worked on was I worked on NetLogo, which was a project by Uri Walensky at Northwestern. So NetLogo is a multi-agent modeling language for teaching and learning, and also building complex systems models. So that's used by everyone from middle school students up to researchers in complex systems. And it's actually based on Logo from Seymour Pappert's original logo. And it's great.
There's turtles in there somewhere.
There's turtles all the way down, actually.
Yep.
Yeah, and it's so that's great fun, and I worked on that for a long time in my grad school. And then,
is there a particular application that you think of in your work with NetLogo that was particularly interesting?
Like a particular model?
A particular area that you did it in, subject matter or application?
You know, so I'm always biased towards thinking about computational thinking and computer science stuff. So I had a lot of fun working with some computer science and systems people building sort of ecological models of AIs living together, thinking about the rules that could create dynamic systems and how complex those rules could be, and that was a lot of fun. It wasn't explicitly for teaching and learning, except for my teaching and learning. But it gets back to that. The way you learn about it is by doing it. Absolutely, and really engaging with the material of sort of this ecological AI stuff was really enjoyable. But I learned a ton. I really got deep into the understanding, a much deeper understanding of it. How about currently or more recently? Are there any other projects you think that really embody constructionism in interesting and unique ways? Interesting and unique ways. There are so many projects that embody great parts. There's so many. How about this? There's so many technologies that can be used in really great constructionist activities. I think that almost any tool anywhere can be used in a deeply non-constructionist way, right? Logo included, right? Anything can be done. You can tell people, okay, class. In fact, that happened in the legacy of Logo, that people took Seymour's ideas of like doing things in constructionist ways and said, okay, today everybody, we're going to learn how to build a house. And literally, I can speak from personal experience. I was in a primary school classroom where I was told by my teacher, this was a while ago, but I was told by my teacher, okay, everybody type in forward space 90. Right? Everybody type right space, well, I guess forward space 10, right space 90. Yep. And we all typed it in. Yep. Hit enter. Yep. What about, I'm sorry, I'm trying to blank on the name of it, the soccer game that you did. Oh, right, so talking about my own stuff. Yes. Yeah, so I have several projects of my own that I've built. So one is we have an iPhone game called iPro, I-P-R-O, which is on the App Store, and it encourages kids to think, so instead of playing soccer by directing the individual players to kick the ball, kids program their own robot to do whatever they want in this constrained soccer space, and seeing the kinds of systems that pop up out of that. The key is they're doing it actually on an iPhone or an iPod, and so they walk around and they test out their ideas with their friends, and so it also engages their sort of body synchronicity, as Seymour might say. By looking at each other's screens? No, by looking at each other. So they do a lot of sort of like, oh, what's my program doing? I need to test out with my arms. I need to walk around the room. We often put a grid on the floor that looks like the grid in the game, so that people can make that map from the real world in their own bodies the way that programming works. And so that's been a lot of fun. In grad school I developed VBot, which was a circuits-based, electronics-based soccer game as well. I've got a project with the New York Hall of Science, which I hope to maybe show you, where we've got kids building circuits to catch virtual monsters, virtual fish.
Monsters and fish?
Yeah, yes. To learn about circuits in an authentic way that you care about building with your friends and care about building in a way that does something with immediate results.